Welcome. My name is Ian Waits, and I'm the head of the Department of Aeronautics and Astronautics. A special welcome and thank you to our speakers today, Norm Augustine, Ed Crawley, Asif Siddiqi, and John Logsdon, and a thank you as well to David Mindell, who's on the end, whose idea it was to host this important discussion and who will serve as our moderator today. I also want to recognize and thank Bill Latante and Sue Whitehead. Every event needs one or two people who make it all happen, and Bill and Sue were those two people for this event, so thank you. Also, I'd like to ask people to turn off your cell phones. This will be a live webcast and it's being filmed, just so that you're aware of that. We are very fortunate to host this panel today, and it's part of continuing a long history of engagement for MIT in the space program and in government service. Earlier this year, we hosted at MIT a celebration of the 40th anniversary of the Apollo lunar landing, and that was an important opportunity to reflect on the past, the present, and the future of aerospace. Much as this event today focuses on a report that looked at lessons from the past and made recommendations about the future. One milestone in MIT's participation in the space program was that we were selected as the first team member for the Apollo program, and under the direction of Doc Draper went on to design the guidance, navigation, control, and computer systems that brought man to the moon. We also educated 5 of the Apollo astronauts, including 4 of the 12 who walked on the surface of the moon. We've continued that tradition at MIT. Today there are 34 astronauts with MIT degrees, and in October of last year there were 4 MIT astronauts on the space station at the same time. We continue to lead in the development of technologies and architectures for space exploration, both human and robotic, ion engines, biosuits, interplanetary supply logistics, and multi-spacecraft control. The contributions of the Augustine Commission are of a different flavor, however, than the designing of hardware or software or the training of astronauts. Rather, they're about rethinking our direction and deciding what is attainable while not losing the excitement, inspiration, and contributions of space exploration. In this way, they're much more like a less well-known contribution that an MIT alum made to Apollo that we learned about during the June celebration. During that June celebration, many of the same people in this room came together to honor one of the former greats of aerospace, Bob Siemens. Norm did it telephonically, and Ed Crawley was here, and Sheila Widnall participated, as did Neil Armstrong and George Miller and Larry Young and Susan Hockfield and Chuck Vest, a lot of very notable people and friends and family of Bob Siemens as well. And many stories were shared at that time. And I think my favorite was a story that Chuck Vest told about Bob Siemens. And it's much like the report of the Augustine Commission because it's about rethinking our direction. Chuck Vest told the story about how Bob Siemens worked for 3 days straight to convince President Kennedy that the right target for America for the space program was not Mars, but the moon. And you can imagine if JFK gave that now famous speech and identified that the right target was Mars, it's very likely that at that time we would not have achieved that. It's very challenging to achieve that today, I would argue. And if we would have fallen short, I think the legacy of the Apollo program would have been very, very different. So I see the Augustine report in much the same light, giving the right guidance at the right time to the highest levels of our government so that they can make appropriate decisions. So with that, I will introduce David Mindell. David is the head of MIT's Science, Technology, and Society program. He's also a professor of aeronautics and astronautics. He's an expert on how automation can change science, engineering, and exploration in the broadest ways. He's the author of Digital Apollo and the main force behind a white paper on the future of human spaceflight, and he's uniquely suited to lead this panel discussion. David.
Thanks for that introduction, Ian. I'm thrilled to see so many students here, not least because, in a way, the idea for this panel really came from students. Come September, way long time ago, at the beginning of the term that's now ending, and it was clear that the Augustine report was coming out shortly, and I started getting pinged by a lot of students about, you know, what's MIT going to do to help inform us about what's going on? And I said, well, that's a good question. Let's start thinking about that. And that's the end of that conversation was the idea for this panel. I want to give a little bit of background on what brings us here today. Many of you, I recognize the faces, are already in this world in a way that you'll be very familiar with this history. And in a certain sense, it begins with the Columbia accident in 2003, when the shuttle program, in a sense, was destabilized. And the report, the Columbia Accident Investigation Board report, of which both our colleagues Sheila Widnall and John Logsdon were members of the commission, really said that the shuttle really ought to be either retired or recertified. That second piece is often missed, by 2010. And in a sense, that set a kind of deadline for something's got to change in U.S. human spaceflight policy, and this was a sort of a different kind of end-of-the-decade deadline from the one that we were so used to with the Apollo story. The Bush administration produced its vision for space exploration in 2004. That generated the Constellation program, which has proceeded since then. And over the course of the following few years, it became clear that as the shuttle was going to retire, there was what was going to be next. And one answer for that had been the Constellation program. And right about that time, there was a particular dinner here at MIT involving me and David Newman, Larry Young, Annalisa Weigel, Jeff Hoffman, and a guest at the time, John Logsdon, and he really said, MIT has a contribution to make to this upcoming huge decision. What are you guys going to do about it? And that was a good challenge that we took on. And really formed this, what became known as the research group in space policy and society. Ian mentioned that group's work, in a sense, culminated with this report. It was almost exactly a year ago. It came out during the transition between the administrations and really addressed the question was, regardless of who won the 2008 election, the new administration was going to have to make major, in a sense, 40-year decisions about human spaceflight essentially within a year of its taking office. And that's a big decision for any administration to make. And we felt there was a role to be played by MIT and MIT expertise in just simply providing some information about how to think about that decision and how to structure what might happen about it, more so than actually saying you should do this or you should do that or go here or go there. Just a few of those issues, all of which I'm sure we'll cover today, are what to do about the International Space Station. It's nearing its completion of construction, how to make the most use of science, obviously, as I mentioned, what to do when the shuttle retires, how to handle the Constellation program, or a larger question of what is America's future heavy lift vehicle for going into space, international collaboration, a very interesting topic that's been changing a lot practically week by week if you read the papers. What are the destinations? Why bother to send people into space at all? What are the goals of an American or international, for that matter, human spaceflight? What about NASA as an organization? What are the issues there? On and on. I'm sure all of these things will come up in the conversation today. In the spring of last year, the Obama administration and John Holdren, the science advisor to the president, appointed the Augustine panel, the products of which we'll hear about today. And they worked quite feverishly over the summer and into the early fall, came out with a preliminary report in September, I believe, and then the more final report, which is in paper somewhat of a rare commodity, so I'm very happy to have gotten my copy from Ed this morning, but it's on the web in PDF for all to see, came out in October, and that's really what we're here to talk about. And so I had the good fortune to be in a meeting with Ed where he gave sort of a 40-minute story about both some of the thinking behind the report and what the recommendations were, and it was just utterly fascinating and interesting, and we decided that was something we really wanted to make available to MIT students, particularly as an educational opportunity, and then to the broader policy community. So that's what brings us here today. We're interested in what's next, what's the political process for going forward, what is actually in the report. Ed, I think, will speak quite a bit to that. What does it all mean? And that's, hopefully our commentators will talk a little bit about that. And as I mentioned, or as Ian mentioned, actually I don't think we're live on the web, but we are going to post the video of the conversation on the web this afternoon and make it available to the broader space policy community. So if you're asking a question, consider yourself on the record in that way. But our primary audience is really the MIT community, particularly MIT students, as an educational moment in what's going on in this thing. Here we are at a pretty important nexus that's probably going to affect a lot of the students in the room and what kind of work you do after you graduate, if not all of us who are in this business on the research end. And here's a chance to hear it directly from people who've been very important in that. I want to thank a few people as well, particularly the Dennis Shapiro 55 Fund, who supported both the Space Policy and Society Group and also made this event possible. The Aeroastro Department, Ian's leadership in hosting the event, and I'm going to echo his thanks for Sue Whitehead and Bill Latant, who really are the top flight professionals in making events like this happen extremely smoothly. You can imagine what if you picture the Venn diagram of these four people's schedules, you can imagine the skill in finding this teeny little 2-hour hole where everybody happened to be free. And I think we're fortunate it happens to be the day after classes are over. Bianca Singletary of STS, who helps me with all of these things. Allison Fox of the Washington office, who really has been a great connection to what's going on in the policy process in Washington. How does that work, and what are ways that MIT can best contribute there? Our panelists, particularly, all of whom have really gone out of their way to be here today and found time in a very busy schedule. So the format today is really Norm's going to speak a little bit about the overall framing of the committee. Ed will come on, I believe, with talk about the content of the report. And our two commentators will then speak about some background. So I just want to close by introducing our panelists, most of whom will be known to all of you. Norman Augustine has a career that really defines engineering leadership. That's a phrase we use around here a lot, and sometimes we ask, what does it mean? And you just have to look at Norm's CV, or even a fraction of his CV, to see what that involves. He's the retired chairman and CEO of Lockheed Martin. He served as assistant secretary, undersecretary, and acting secretary of the Army, chairman of the National Academy of Engineering, the Defense Science Board, the Aerospace Industries Association, president of the American Institute of Aeronautics and Astronautics, and has been very active in a great number of other important advisory boards for NASA and for the Department of Defense and other technological agencies. One of those notable ones is he chaired the National Academy of Sciences panel that produced the report Rising Above the Gathering Storm, which really addressed very important issues in engineering workforce in the global world in 2006 that has had a major impact on what MIT does and how we do it and how we think about it going forward. He's not an MIT alum, but he might as well be. He's had a lot of involvement with MIT. He's been a member of the corporation. He's been the chairman of the Engineering Systems Division Visiting Committee. And you can find him even on video on MIT World within the last 6 months or so at the Engineering Systems Symposium, talking about a more technical topic about what is engineering systems. We're very happy to have Norm here. He's also a recipient of the highest medal for engineers in the country, the National Medal of Technology, which is awarded by the President of the United States. Ed Crawley also will be known to many of you. He's the Ford Professor of Engineering at MIT and Professor of Aeronautics and Astronautics, as well as a Professor of Engineering Systems. He's a former head of the Aero and Astro Department. He's been the director of the Cambridge MIT Institute, director of the Bernard Gordon MIT Engineering Leadership Program at the moment, and his research focuses on the domain of architecture, design, and decision support in complex technical systems. And I think it's very interesting, and it'll come through implicitly, if not explicitly, certainly if you read the report, wonderful example of how the most technical research at MIT, in a way, Ed's work on architecture has fed into this national policy decision. The distance between the content of the engineering and the national policy here and the research that goes on campus and how policymakers right up to the presidential level, think about technology is really embodied in Ed's work and his work in this report, and I think that should be noted. He's a member of 3 academies of engineering in the United States, in Sweden, and in the UK. John Logsdon is Professor Emeritus of Political Science and former Director of the Space Policy Institute at George Washington University. I'm happy to say he's also a distinguishing visiting professor here at MIT with our Space Policy and Society Research Group, and more than any other person really defined the field of academic study of space policy. He wrote really the seminal study on the field, which is called The Decision to Go to the Moon in 1970, or was published in 1970. I'm sure it was written before that, and is really the paradigm study of presidential decision-making on space policy issues. And we asked him to be part of the panel not only because of his many years of friendship and mentorship to those of us here at MIT working on space policy, but also because he's really got the 50-year context for this current presidential decision. And his current work is actually going back to revisit the Kennedy legacy in space outside of Apollo, including Apollo, but all the other impacts that Kennedy had on the space program. Professor Asif Siddiqi is Assistant Professor of History at Fordham University, also a member of the Space Policy and Society Research Group. He spent the year here last year working on the white papers and also on his own work, and is really the leading light in the new field of space history. Asif, by training, is both an electrical engineer and a historian of technology. His new book is The Rocket's Red Glare, Soviet Imaginations and the Birth of Sputnik. And he's also written really the definitive book on the Russian moon program called Challenge to Apollo, the Soviet Union and the Space Race. And what I love about the book is it's probably, what, a 1,000-page definitive volume on the Soviet lunar program, and he wrote that book. And then he decided to go to graduate school in the history of technology. And he's currently editing a 5-volume set that's really the memoirs of the Soviet Russian rocket engineer Boris Chertok, the first 2 or 3 of which have been published through the NASA History Office. And I asked Asif to sit on the panel because he's also currently working on a history of the Indian space program and has been working as part of our Space Policy and Society group a lot on the relationship between India, Russia, China, and the United States and other countries as well. And I don't want the global implications in the international partnership section of the Augustine report to go unnoticed because they're a major part of what's happening. So I'll sit down at this point and turn it over to Norm.
Well, thank you for that kind introduction, and good morning, everyone. It's always wonderful to be back at MIT. I have so many friends here from over the years. I appreciate the kind introduction, although you plugged everybody's books except mine. And Meg Whitman, that runs eBay or ran eBay, tells me that one of the most sought-after collector's items on eBay are unsigned copies of my books. So take it from there. I'd like to offer just a little tidbit that I was thinking about on the airplane coming up here that for you to think about as a homework assignment. It's kind of interesting that I realized that this is a piece of trivia, that the time that elapsed from the Wright brothers flight to Sputnik is almost identical to the time that elapsed from Sputnik to today. And the time from Sputnik to the time Neil and Buzz landed on the moon was about 1/4 of either of those 2 times. Just food for thought in the way of background. The Committee on the Human Spaceflight plans was in fact set up by the White House to review the current human spaceflight program and to offer options thereto, including, of course, the existing program. We were asked not to make recommendations, presumably so as not to make it more difficult for the President to make a decision. And we've tried to abide by that. Nonetheless, if you look at the parameter space that we had to deal with, there are over 3,000 options that we had to consider, or at least that were possible to be considered. And so obviously to narrow that down to a meaningful set of options to present to the President, we did have to make some decisions and recommendations. But as you'll see as we go through our report summary, we have avoided specific recommendations And that's led to some disappointment in our report, I think, because there were many people who were hoping we would go, say, go to Mars in 10 years or within a decade or something, and we didn't do that. Our committee hired the Aerospace Corporation to work for us directly for the committee, not through NASA, and to provide us with technical and costing assistance. We also got wonderful support from NASA, a huge effort that they provided to assist us, and we're very appreciative of that. We kept Administrator Bolden and John Holdren informed as we did our work, but the report was entirely ours, and I'm happy to say it was a unanimous report in every respect. The membership, just briefly, because these people deserve, I think, a lot of credit, and unfortunately I've gotten more than I deserve, but Wanda Austin is Dr. Wanda Austin is the president of the Aerospace Corporation. Bo Beamick is the head of the orbiter program for Boeing. Dr. Leroy Chow is an astronaut, 4 missions into space, including EVA. Dr. Chris Chiba, a professor of astrophysical sciences at Princeton. Dr. Ed Crawley, you all know very well. Jeff Greason is CEO of XCOR. Dr. Charlie Kennel is the Vice Chancellor at the University of California, San Diego. General Les Lyles ran most of the Air Force's space and ballistic missile programs. And Dr. Sally Ride, you probably know, of the first woman in orbit. And myself, an unemployed aerospace worker. I can't go without saying what a huge impact MIT had on our report. And that impact was through the gentleman sitting here, my good friend Ed Crawley. This committee I probably worked on at least 100 studies like this for our government over the years. Never have I worked with one that worked harder. The committee basically gave up their entire summer, Saturdays, Sundays, the whole thing, to work on this, and nobody devoted more effort. But his impact was just enormous, and through him, MIT's, in bringing systems engineering discipline to a public policy issue. And if you look at our report, in many respects, you'll think you're reading a technical document. And of course, most of the equations that are behind it aren't in the report, but believe me, there are a lot of them. It was a highly technical undertaking. The plan here, Ed and I kind of split up the discussion here. And what I plan to do is kind of give a quick summary of the existing program and where it stands in our view. And then he will talk about looking forward at the options that we've offered and for future considerations. In terms of the existing program, there are several pieces of it. Obviously, the biggest, most prominent is the space shuttle. And what does one do with the space shuttle? There are arguments to continue it. It's become quite reliable. It's very expensive to operate. It carries a very large payload. We have all the logistics set up to support it. On the other hand, it does have the problem that it consumes a great deal of money in the near term. The space shuttle is scheduled, I should say when I describe the current program, I'm going to describe it quite literally. There are other people who have different views of it. This view is the NASA work scope, the OMB budget, which is as close to ground truth as I know how to get when you look at future undertakings. The space shuttle is scheduled to be completed in FY10. It has 5 more flights to be conducted. Second major element of the existing program is the International Space Station, now on orbit, some 900,000 pounds up there, really an amazing construction. And the current plan that has been in place for some years would be to shut it down in 2015 and deorbit it for safety reasons. The new program that it's an ongoing program, new program, It's called, of course, the Constellation Program. It consists of several parts. The Ares 1 is a launch vehicle that is in development at the present time. The Ares 5, just barely getting started, will be the heavy lift launch version of the Ares. The Orion is the capsule, much like the Apollo capsule, except with today's technology, going back to that sort of an approach. And the Altair is the lunar lander, which has not yet really begun other than in conceptual design. The next step in terms of our work will be for the President to decide whether he wants to pursue the existing program or some alternative thereto. And I'm told that some of the decision documents are on his desk right now, but I gather he has a few other things to worry about as well. Quickly going through some of our findings is relate primarily to the existing program. Our most important, I think, overall finding is that the existing space program we're pursuing, human spaceflight, important to emphasize we didn't get into the robotic spaceflight program, other than as it directly impacts the human spaceflight program, which it does in some areas, of course. Our conclusion is that we are on an unsustainable trajectory today, and there's a very simple reason for that, and that is that the means don't match the ends. The budget resources don't match the work scope, and that's a very dangerous place to be in our view when you're dealing with human spaceflight, because if there's anything that's unforgiving that I've ever been involved in, anything that doesn't tolerate cutting corners, it's spaceflight, particularly human spaceflight, where the consequences of failure are so enormous. One of the difficulties that NASA suffers from and has long suffered from is that its budget has always been too tight compared with what it was trying to undertake ever since the Apollo program. And one consequence of this is that to start a new program, it has to stop the existing programs to make money available for the future. And this was a concept or a notion that was first pointed out that crisply by Ed. And it is true that we find ourselves then creating gaps where we shut down what we have and then we build something new, and meanwhile we don't have anything to pursue. And we'll come back to that a little bit. Turning to the Ares 1 and the Orion, they've encountered some non-trivial technical problems. It's our view that those are problems not unlike those that are encountered in any very difficult engineering undertaking and are probably solvable. It will impact their schedule, though. The question with regard to the Ares 1 launch vehicle is not so much can it be built as the question is should it be built. And with the current budget profile, there's a mismatch between the availability of the Ares 1 and the tasks it's intended to carry out. And that's one of the dilemmas that NASA is having to deal with. The Ares 1 program has been underway for 4 years, and during that 4 years it slipped about 5 years. And of course that has a huge impact on how it fits with the overall program. The 5 years is our view, not necessarily NASA's view, although I don't think NASA's view is vastly different from that. The Ares 1 had a near-term objective, which was to support the International Space Station. The problem is with the current budget profile, the International Space Station will be in the South Pacific 2 years before the Ares 1 is available. With the extended International Space Station schedule, the Ares 1 would probably be only available for maybe the last 6 flights to the station, about 3 years worth or a little about that. The longer term, it's intended to support the Constellation, which targets an established presence on the moon. And the challenge that we face there is that there is not any money going into establishing a presence on the moon today, because that money has all had to be sucked forward to work on the the Ares 1 and the Orion. So we sort of have a dilemma dressed up for this party and no party. The third thing I would like to address in the way of findings relates to the possible extension of the ISS. As I said, it's intended to come down in 2015, and there are many good arguments. Some of them, particularly importantly, are political arguments that many of our allies, our colleagues in other countries that have been supporting the International Space Station have made major investments, and they don't understand why, after working on this thing for 20, 25 years, we would only operate it for 5 years and then shut it down. And that's not necessarily a sunk cost argument, because if you look at the benefits of operating it for another 5 years, they could be rather significant, particularly if there's enough money put in the budget to fund the science that could be conducted there, and perhaps even more importantly, fund the engineering that could be done there. The current program recognizes a 5-year gap in the U.S. ability to place astronauts in orbit to the ISS, for example. And this gap is created by the sort of circumstance I described a moment ago. And it's likely that for that 5 years, the only way to get a U.S. astronaut into low Earth orbit will be to buy a seat on a Russian launch vehicle. And in our view, the gap is more likely to be 7 years than 5 years. We also raised a concern about the shuttle flyout rate, which is about double the experience since the Columbia failure. And we've recommended that funding be put into 2011 so those last 5 flights could be done at a bit more leisurely pace. And we don't have the slightest concern that NASA would do anything unwise or get in a hurry. NASA is very conscious of the safety issues here. On the other hand, it's not wise to have that budget pressure on the people who are flying the shuttle. We think that it's very important that there be a strong technology program, well-funded, including such things as work on liquid engines, which we've largely neglected, and certainly on things like refueling in space. We also noted that there is really no program at the existing budget level which is a meaningful human exploration program, that one does need to add funding, probably about $3 billion a year, ramped up over the next 4 years from today's budget to the $3 billion add-on. One might say, how did we get into this spot? The best I can say to you is at the time the Constellation program began, at least I'm convinced that the leadership of NASA honestly believed, based on conversations they had with most everybody, that a certain budget profile would be available, about $10 billion a year. As it turned out, that was an incorrect assumption, that not that much money was ever available in OMB's budget plans. Furthermore, there were budget cuts that occurred subsequent to that. And furthermore, there were technical problems that occurred that absorbed money and required money to be moved forward from working on the lunar lander and so on. We have offered a number of programs at a somewhat higher budget level, about $3 billion a year, which we think could be very meaningful. Professor Crawley will describe those, and he will describe the eventual goal, and I'm sure he will make the point that we tried not to start with destinations, but we tried to start with goals. What is it we're trying to accomplish? What's our objective? We think too often people have sat down and said, okay, let's go to the moon or let's go to Mars. About 2 or 3 more comments. One is that there's a clear need for a heavy lift launch vehicle in our view. An Ares 5 type vehicle is probably a very good candidate. We also believe that this is the time to try to create a commercial market to low Earth orbit. If NASA spends its limited budget just hauling people to low Earth orbit, it consumes so much of the budget that there's just not much left to do interesting exploration. We would like to see the commercial world have a greater role in getting both payloads, both people and cargo, to low Earth orbit so that NASA can focus on going beyond low Earth orbit and doing some of the really exciting things that it has the capability to do. I might also note in that regard that many years ago when the airlines were struggling in this country, you'll recall that the U.S. government gave guaranteed contracts to haul the mail. And that's what made the U.S. airlines viable, if that's the right word in today's perspective. Something like that is what's probably needed in the commercial space launch sphere. We emphasize the importance of international programs, not only for political reasons, not only for cost-sharing reasons, but also for technology-sharing reasons. We no longer stand head and shoulders above the rest of the world in space technology. There are others with very important contributions to be made, and we would hope that we could focus on cooperative international programs. Lastly, it's our view that the NASA administrator needs to be given the authority to manage NASA. Now, that may sound like a rather trivial observation, but I don't think it is. The last several bills that have come out of Congress with funding for NASA have said that the NASA administrator could not use any of the funding that's provided to reduce the workforce or to close facilities. And when you're operating a very high fixed cost operation, as is NASA, and have very little latitude to do anything about it, one of the consequences is that even small budget cuts cause enormous schedule slippages in programs. There's a huge amplification factor. You can go through and do the calculation. And it's our belief that the NASA administrator has got to be given some latitude to manage the programs. It's probably not his role to decide what programs we should pursue, although he should certainly have a major input, but it certainly would be his responsibility to carry out those programs, and he deserves to have the authority to do that. And so with that, I will stop and turn the podium over to my colleague, Ed Crawley. Ed?
Excellent. Thanks. Well, thank you, Norm. It was, as one can expect, a marvelous summer of tutelage doing this exercise at the side of Norm. And in particularly, I had the opportunity to do my first congressional testimony along with Norm in September, and I'm darn glad he was there. One of the things that I want to say for the MIT audience is to demonstrate how what we tried to do at this exercise was apply just good, solid system engineering. But it was the system engineering of a fairly complicated question. It was the coupled issue of what should a policy be for the nation's spaceflight program, human spaceflight program, and what should be the technical architecture that supports it. So we were, during the summer, essentially working at two levels. Working at the policy level, and then making sure that the policy recommendations that we made were supported at least by feasibility arguments, that technical solutions could be found within reasonable budget parameters that would allow those policies to be implemented. And as Norm said, we were very aware of two things. One is we weren't going to give NASA more than it could do for its budget. That we weren't going to come out with a report of marvelous spacemen and women flying around to places that we don't have money to get to. And we were not going to tread on the legitimate concerns of the scientific community and promise science in human exploration that was unsupportable by the priorities of the scientific community. So we had enough scar tissue on this collective group of people that we'd been around these circles before. So when one starts with system engineering approach, one says, what are the goals? So although we were not chartered by OSTP to do so, we decided to restate the goals, as you can see here, in, I think, a fairly good workmanlike way, that there are more tangible benefits of human spaceflight, that you prepare for exploration, that you interact with science in a credible way, that you develop technology both for space programs other than NASA. And remember, NASA's is the third largest space program in the nation. The commercial and defense programs are larger, and NASA has a role given to it by the Space Act of '58 to produce technology for space exploration and development, not just its own, and economic development and development of the industrial base. There are these less tangible benefits, often cited, engagement of the youth, getting people to come to MIT, want to be astronauts, and so forth. And our argument here was, if we're going to take credit for these inside the Beltway as reasons we go into space with humans, we better produce a spaceflight program that actually inspires the youth, and not one that looks like, quote, Apollo on steroids, end quote, as was described by the former administrator. But remarkably, amongst this group of some hardcore engineers and some generals and DoD space people, some scientists and some engineers, academics, we very rapidly identified what we really thought was a vision for the ultimate exploration by humans of the inner solar system, which is to go to Mars. That it was very strong consensus in the group that Mars is the ultimate destination for human exploration in the inner solar system, and that what we do should lay the groundwork to get to Mars. So this is a arguably 30, 40, 50-year commitment, but it's an appropriate time to begin. And that these goals should drive the consideration of destinations and of systems. So in a system engineering-like way, we wanted to identify measures and metrics of what was goodness in achieving these goals. And we identified 12 measures that we would apply to the programs that we developed, which you can see traced from this thinking we did on goals, but also, as you can see by the chart, are traceable to some of the long-standing policy documents of the nation. The Space Act of '58, the Vision for Space Exploration of 2004, the Global Exploration Strategy of 2007, an international document, and the OSTP Guidance of 2009, which within the Washington community would instantly be identified as the guidance from a Republican, a Democratic, and an international community. So the argument being that if there are these commonly held measures of goodness for space exploration, we're probably we're standing on firm ground by applying them. Exploration, preparation, development of technology, enabling the discovery of new scientific knowledge, expanding human presence, engaging the public, economic expansion, and global partnerships are what you might call benefit measures, schedule and programmatic risk, mission profile safety, workforce impacts, programmatic sustainability, and life cycle costs. And we developed rubrics for each of these 12 measures that allowed us to rate programs on a -2, -1, 0, 1, 2 scale. So the committee went into the evaluation process. Remember, we're asked not to make recommendations, but to define alternatives and evaluate them. So as an early part of our process, we decided on this evaluation set of rubrics. So in 2005 or so, MIT and the Draper Laboratory took part in the CER, Concept Evaluation and Refinement, if I remember correctly, study, in which we developed a really nice simulation of a discrete event simulator, essentially, of how you would go about exploring the moon and Mars. And at the end of that, we presented this to many senior policy people and Washington decision makers, and they said, boy, this looks really like really good work, but where are the decisions? Because one of the things that's sort of a tautology is that decision makers make decisions. Right? So this actually led to the work of Bill Simmons, a recent doctoral student of mine, where we tried to recast the description of architectures of complex systems explicitly parameterized in terms of the decisions that decision makers would have to make about them. And when we went into this study this summer, as Norm alluded to, I explicitly sort of carried along this bag of tools with me and had the intent of defining the study that we did and the option space that we investigated explicitly in terms of the decisions that the decision makers would have to make. So that on the morning of August 14th, when we went to OSTP to brief out the interim reports of the committee, after Norm did his introduction, turned it over to me, I looked at John Holdren, the presidential science advisor, who, by the way, has 2 degrees from the Aero Department at MIT. And I said, John, there are 5 decisions you have to make about the future of U.S. human spaceflight. Here they are, and here are the options and our evaluation of them. And he later said to me, this was one of the most clear presentations of a decision space of a technical and political problem that's been presented. So thank you, Bill Simmons. One of our colleagues did this. So I want to sort of take you through the first decision. The first decision, having established the goals, is what is the destination? And this sort of represents the decision logic of the committee over the course of the summer. We started up in the upper left-hand corner there, and we said, well, we got all these things. We got, what do we do with the ISS? What do we do with the moon? Is there something other than going to the moon and Mars, which we ultimately call the flexible path? Could we go to Mars? And what very interestingly happened, also surprisingly, was that we embraced the ISS as not a problem but an opportunity. This was not a group of ISS lovers. Charlie Kennel, while he was the chair of the NAC, actually got in trouble in the press by disparaging the ISS. Some of the astronaut community does not think very highly of it. I spent much of my early career helping defend it and wondering if I had spent that part of my career well. The fact of the matter is that the ISS has now been a program of NASA for about 27 years and is only becoming a viable research laboratory now. It's been an integral part of the human spaceflight program of our partners for over 20 years, and they have only put their crew and their modules in space in the last year. So given this proposition, you say, is it time to start the decommissioning process of the space station? Because it's a 3 or 4 year process to decommission the space station. You know, we've never deorbited anything, any fraction of the mass of the space station. In fact, we don't have a stage with enough impulse to deorbit the space station. It's $1 billion effort if you want to deorbit the space station to build a stage to deorbit it. Right? It's sort of like a nuclear reactor. I mean, there's expenses in shutting it down. There's expenses in keeping it going. So, especially under the impulse of the influence of our international partners, who essentially said, if the United States is ever to lead an exploration effort in space again, we better have an opportunity to utilize the space station. We moved it into the solution column and said, let's use the ISS as a stepping stone. There is research, preparatory research, that we can do for exploration beyond LEO at the ISS, and that left the destinations. The next thing we realized, and we did scenario-based strategic planning. We created 8 scenarios during the course of the summer of future human exploration. We looked at the good and bad attributes of them. We did Pew analysis. We recombined the good aspects of the good ones to create and winnowed it down. In this process, we realized that Mars is not the first place to go. Bob Zubrin and a very loyal constituency notwithstanding, it would cost us more money than we have, and it would be all we could do for at least 20 years, and it would probably not be safe. So we took Mars and we moved it out of the initial column, and we moved it as the ultimate destination in the inner solar system. Notice I always say in the intersolar system, because there are those who believe that we will go outside of the inner solar system with humans, but probably not in this century. So that left as the initial destination these 2 ideas. One is the tried and true, John F. Kennedy will go to the moon, which as Norm observed, or who observed this morning, Ian observed about, was cooked up by Bob Siemens and several other people 3 days, 1 weekend at the Pentagon working. Or another option, which we'll call the flexible path, which I'll describe, which is really has as its essential idea that you don't initially go down into the deep gravity wells of the moon and Mars. That you expend the energy to get to low Earth orbit, and you expend the energy to escape low Earth orbit, and then you more or less just float around. Because if you don't go into the deep gravity wells of moon and Mars, you can actually visit all the other destinations, including flybys of planets in the inner solar system with only a meter or two, a kilometer or two per second of delta V. It becomes a very benevolent environment as opposed to the very energetic environment of getting to Earth orbit and then escaping Earth orbit. So we said, which of these comes first? Well, then we realized, which of these do we do? Then we realized in the lower left-hand corner that, in fact, you would do both of these on the way to Mars. That it's desirable to go and learn how to work on a planetary surface. That is the moon. But we argued if humans went for a decade or two and worked on the surface of the moon, but were never more than 3.5 days away from Earth, would a president then ever commit them to a 900-day mission to Mars? Highly unlikely. So what the flexible path does is it allows you to gain progressively more experience working outside of the radiation belts, having more and more complex encounters with other planetary bodies, asteroids, and near-Earth objects, and ultimately the moons of Mars, so that you do 20-day missions, 50-day missions, 100-day missions, all of them scientifically interesting and operationally interesting, but along the way building up the capacity to work in free space. So basically, you got two options: learn to work on a planetary surface or learn to work in free space. Which one do you need to do before you go to Mars? Yes. Right? You need to do both of them. So really the only question left, if you think you're trying to get to Mars, is what order you do them in. Do you do moon and then the flexible path, or do you do the flexible path and then the moon? So as a result, the fifth numerical decision, but the first one logically, is how do you go, what is the destination? And our argument was the Mars first option we removed, and this leaves the president essentially two choices: to continue along the path of going to the moon as the first principal destination, or to go on the flexible path. Now let me add a programmatic interpretation that will make our reasoning much more clear. In order to go to the surface of the moon, you have to develop the heavy lift launch vehicle and the capsule, Ares 5 and Orion or something like them. And you have to develop the lander, another $15 or $20 billion. And you have to develop the lunar surface infrastructure, another $15 or $20 billion. To go on the flexible path first, you have to develop the heavy lift launcher and the capsule, and a few $1 billion worth of in-space hardware, allowing you to start exploring beyond low Earth orbit with that set of equipment while you do the capital investment in the lunar lander and lunar surface infrastructure, and then come back in later with the lunar surface program. So if you had to manage these two possibilities within a budget, it's pretty clear which one fits more naturally within the budget. Just another view of this. This is the change in change in velocity from low Earth orbit versus a sort of notional increasing mass and increasing duration. And these are the various places you can go. And you can see on this flexible path, you can actually do a lot of these things with a fairly modest impulse from a delta V from low Earth orbit. When we talked about going to the moon, we actually created an alternative scenario, which is a more, we called it lunar global. And it focused more on going to different parts of the moon for shorter stays of increasingly longer progression rather than developing a base. We also had a base option. And it turns out at the cost level, these things are indistinguishable. It's largely the details of the hardware you build. But we argue that the lunar global is more representative of the way in which you would explore the Martian surface. You would probably not want to build a base on Mars. You would probably want to go to different scientifically interesting places. Let me just say a few words about the flexible path, which has actually attracted a lot of interest. The argument here is you do what you can do with the hardware you have as you build more of it. And there are some very interesting things you do. You go to some of the Lagrange points, you go to the near-Earth objects, and then you can decide if at that point you go to the lunar surface, or you do a Mars flyby, or you go to Mars orbit, or you eventually go to the Mars surface. And it gives what our colleague Richard de Neufel would call real options to the planning staff of NASA in the future. That there isn't a single path that we have to go along, that based on what we discover, budgetary constraints, technological capabilities, you make decisions over the next few years' planning horizon. What would you do at all these things? Actually, there's some very interesting things. A lunar flyby is more or less to demonstrate that we can do it. It's a test flight, essentially. Going to the Earth-Moon L1, the Lagrange point between the Earth and the Moon, allows you to potentially demonstrate servicing of scientific spacecraft that would be brought there. It's about a 21-day mission. You go to the Earth-Sun L2, where James Webb Space Telescope will be, demonstrate servicing of scientific observatories there. The Earth-Sun L1 is the first time you really get out of out into the real solar wind, out beyond the magnetosphere of the Earth and its plume. The really interesting target is to go to NEOs. There's a lot of interest in NEOs. You know, you're more likely to be killed by a near-Earth object than lightning. For example, lightning happens more often, but near-Earth objects kill us all. So statistically speaking, near-Earth objects are pretty dangerous. And then do a Mars flyby and so forth. Norm discussed decision 1, the shuttle life, decision 2, the ISS life. I'll just say a few words about launch to LEO and crew and then get off the stage. We tried to actually really examine a range of possibilities for heavy lift. Norm said there's a need for heavy lift. Let me give you the gut feel. Is that in the era of exploration beyond LEO, either going to the moon or to Mars, the explorer nations will have to launch something in the range of 600,000 metric tons per year. Right? Now, the space station is around 350,000 tons. Do I have that right?
You got an extra 1,000.
I got an extra 1,000. That's why I hesitated. The space station is, I was thinking in kilograms, I'm sorry. The space station is about 350 tons, and we will need to launch in the range of 600 tons a year. It took us a decade to build the space station with the shuttle. So that every year, we will have to, as part of an exploration program, we will have to launch twice as much mass to low Earth orbit as we sent into space in a decade to build the space station. Right? So you're not going to do it in chunks of 20 or 25 tons. So what we did is we looked at directly shuttle-derived vehicles, Ares 5 light, I'll describe that in a second, the Ares 1 plus Ares 5, or a more EELV. Well, it turns out the distinguishing feature of the shuttle-derived vehicles, although they're attractive from a workforce continuity perspective, is that they have a very expensive engine in it. The SSME and its derivatives are on the order of $100 million each. And when you launch that much mass into low Earth orbit with SSMEs, you would buy about $3 billion worth of engines a year. That's not a sustainable path, likely. On the other hand, we tried to get NASA out from under, using the ELV heritage, this deep commitment to its Apollo shuttle legacy infrastructure, which really is a heavy recurring carrying cost that the NASA budget carries. And this is basically more a business model. It says not only does NASA get out of the commercial crew business, it gets out of the cargo business and turns it over. And in essence, the transition costs for doing this, of closing NASA facilities, laying off NASA personnel, terminating NASA contracts, and so forth, would make any benefit of this not occur until the next decade. And therefore, I suspect it's unlikely as a political decision. So it left some variant of the current NASA program as the likely ones in the middle, and we evaluated these two pretty carefully. So the last decision that I'm going to talk about is how we get the crew to orbit. So the reference case is that we use the existing Ares 1 and Orion, which, as Norm indicated, are very capable systems which will eventually sort out their technical problems and become available. The question is, will they become available soon enough to service the ISS, and in all likelihood just barely catch the end of it? So if one of the motivations to build the Ares 1 and Orion is to service the ISS, it sort of just about catches it the last year, 2, or 3. The second problem with the Ares 1 and Orion is that it's a very capable system, which sounds good until you have to pay for it. That means it's a very expensive system. It's a system designed the capsule in particular, to go to Mars, which you're using to go to a place 300 or 400 miles away, low Earth orbit. And you would carry that carrying cost each time. So subject to policy guidance from all of the 2008 Appropriations Act, the 2008 Authorization Act, and White House presidential directives, all of which direct NASA to utilize commercial crew services to LEO to the maximum practicable extent. We looked at the commercial crew option and concluded that there was a viable possibility here of building a simpler spacecraft and using an existing or in development high reliability rocket with a launch system that we thought had the chance of significantly reducing the recurring cost to NASA at the same level of safety that the Ares 1 and Orion would be. Keep building the Orion, but use it for what it's really intended for, which is go to the Moon and Mars, and develop a simpler system for crew delivery. We also recognize that this is a big bet. And if I were the NASA administrator, I would not take this bet without an insurance policy, some sort of real option that allowed, if this didn't work out for a variety of technical or business reasons, to default to some other alternative. And we proposed several in the report, probably the preferable one being to use the heavy lift vehicle as the backup for the. So I just will leave for your reading pleasure the way that we took the 5 decisions represented here and created integrated options. And then we examined within Monte Carlo-based statistical simulations of cost-schedule interactions, the likely playouts. And here is what the current program looks like at the top. The current program, assuming you don't extend the ISS, turns off the ISS in late 2015, and you notice that you don't get to a lunar landing until the mid-25s. So that we would basically have 8 or 10 years of Gemini, of sending crew into orbit with no place, no specific destination to go to. And we thought we could do better than this. So we tried to extend the space station, but keep the crew access by going to the commercial suppliers, or use the shuttle backups as shuttles backup. None of these actually accelerated the access to the moon. So it's not getting to the moon in the early 20s, it's getting to the moon in the mid-20s, and this is 65% confidence level. So the advantage of doing the flexible path missions is you get out of low Earth orbit, even having extended the ISS, you get out of low Earth orbit by the early 20s, and you start going a new place every year, a cadence of successes of going to various destinations and doing new things that will engage the American public and stimulate the youth. So I'll leave it there and let John pick up.
Thanks, Ed. Pardon me. It's 48 plus years since the first human went into space, and we're still arguing about it. Why? Because the reasons for doing it aren't totally clear, as Ed suggested, and really not subject in their totality to any kind of hard calculus. So one of the things that David asked me to do is put this current report and the context in which it exists in some sort of historical perspective. And I count 5 earlier times in the history of the U.S. space program where there have been fundamental decisions on the future of human spaceflight. Let me run through them very quickly just to show you that what Norm and his colleagues did was not unique. It's part of a heritage of, as you said in the report, pulling up the roots of plants to see how they're growing. First was the transition between Dwight Eisenhower and John Kennedy. Eisenhower was not a believer in the value of human spaceflight, put no money in his last budget for human spaceflight beyond the Mercury program, left that decision to Kennedy. Kennedy's first instinct was, let me think about it for a while. But then came Yuri Gagarin. Kennedy, on April the 20th, 1961, wrote a memo to Lyndon Johnson, saying, find me a space program which promises dramatic results in which we could win. And that was the charter for Apollo. So there was, within 3 months of entering the White House, Kennedy set us on a course that has had forward momentum that's taken a long time to dissipate. I think it finally has. A lot of this happens, by the way, at transitions between administrations. The next time was the transition between Lyndon Johnson and Richard Nixon, when it was clear we were going to land on the moon, that Kennedy's goal was going to be achieved in the next few months, and Nixon was advised by his transition task force that there needed to be some thinking of where to go, what to do after Apollo. There was a group set up, chaired by a well-known space expert named Spiro Agnew. You have to be old to recognize that joke, by the way. It's for students, somebody tell you. Apollo 11 happened July the 20th, 1969, and the report of this group came to the White House at September 15th of 69 and said, Mars is the objective, and laid out a variety of options, including a Mars mission launched in 1981. And Nixon said, not interested in doing that. And finally reacted to the report saying, space has to become part of normal politics. It's not special anymore. And that's given us the policy that's guided the decisions over the last 30 plus years, by the way, is having spending on space, the funding level for space, be the result of a normal interplay of political factors rather than being treated specially. The next occasion, I think, was the 20th anniversary of Apollo, when George H.W. Bush got up on the steps of the Air and Space Museum and said we should go back to the moon, this time to stay, and then on to Mars. Strangely enough, that recommendation came through a reconstituted Space Council headed by another space expert vice president, Dan Quayle, and NASA didn't want to do it. NASA said, we're perfectly happy getting the shuttle flying post-Challenger and finishing the space station. We don't think we're ready to take on exploration beyond low Earth orbit, and fundamentally killed the program by a $500 billion budget estimate. This upset the White House no end. They called Norm Augustine and said, what's wrong with this place? And Norm and his group then came back with a report that said, increase the NASA budget, it's not adequate, go as you can pay, and the destination is Mars. And then Bill Clinton got elected. The Bush administration was ready to implement that guidance, but they were voted out of office. Clinton's first recommendation for space from his budget director, Leon Panetta, was cancel the space station, which fundamentally would have meant the end of U.S. spaceflight, because the shuttle wouldn't have had any place to go. It's kind of like Ares 1 launching to nowhere. The shuttle had been doing it a long time. A very intriguing idea came out of a very unusual source, a letter to NASA Administrator Dan Goldin from the heads of the Russian space program and the Russian largest space company, Energia, saying, why don't we combine our human spaceflight programs? Goldin took that to the White House. They liked the idea for political reasons. That led to the International Space Station. And I think without adding Russia, the station would have died. It's not clear what would have happened, whether that would have been, as Ed suggested, would that have been a good thing or not back in 1993, but it didn't happen. And then there was the situation after the Columbia accident. I gave my summer of 2003 up working on the Columbia board, and it was a worthwhile experience. We said in the Chapter 9 of the report that there had been a failure of national leadership in not providing a guiding goal for the space program. The White House read the report, agreed with us, and that led rather directly to the vision for space exploration announced by George W. Bush in January of 2004, and then hiring Mike Griffin, totally committed to exploration, to turn that policy into a program, which he did. And that program is what is now the program of record. As the Obama transition team looked at it, they said, before we embrace this as Mr. Obama's space program for the 8 years we're sure he's going to be there, we better take a look at it. Augustine, too. So let me just make a couple of comments about how this report looks from someone who spends his time inside the Beltway. One of my former students, now fairly highly situated in the space policy environment, said the report was like throwing a grenade into a room. And, blew everything up that was already there, and the challenge now is to put things back together in a useful and productive way. The report said some things that all of us that pay attention to the program already knew, but it was very useful to have a group of this standing to say them, like that there wasn't enough money to execute the program that we were pursuing, that we're not going to fly 5 shuttle missions in 8 months between February of 2010 and September of 2010, that it makes absolutely no sense to leave the ISS after 2015, and that NASA had to change, that NASA's business as usual model was no longer viable. And I think all of us kind of knew that, but it's good to say it. The report does say some new things. It says, and it's the most troubling thing the report says to NASA, that others than NASA can carry people into space. This is a challenge to NASA's, at least the human spaceflight part of NASA's almost soul, that it's not the unique place in the United States to can do that safely and not affordably. As Ed said, it's a high-risk proposition. Having a group of this character and this experience legitimize the notion of commercial, entrepreneurial or not, space, non-NASA human spaceflight is a pretty radical proposition. The need to restore a significant technology program, given the budget constraints that NASA was operating under, the first thing that got gutted and hurt places like MIT when Griffin took over was the technology program. That echoes of Augustine 1. With a budget growing 15% over the next few years, you can have a decent program, but you still can't afford a lander. And that a much more open approach to international involvement is needed for success in long-term sustainable human exploration. All right, just finally, what's happening now? The report defined fundamentally, in my mind, a trade space. At one point, you have the current program on the current budget, which the report says isn't viable. On the other hand, you have, let's say, the flexible path option with a budget ramped up over 4 years of $3 billion extra. That ain't going to happen. There's no inclination in the current economic and political situation to put NASA on a path of that much of a budget increase. So NASA is intensely working on options, somewhere in between, and working closely with the White House Science Office and with OMB as OMB takes the lead in putting together the budget that Mr. Obama will present to Congress on February the 2nd, I think is the date. There's early interactions, but not very formal, with potential partners. The proposition, I mean, again, Norm's group couldn't do it. The $3 billion extra a year could include values of $1 billion or $1.5 billion of worth of contributions a year from non-U.S. sources. That's not accounted for in the report properly. You couldn't do that. So there is, in the next, I think you said, Norm, papers on the president's desk for decision. I don't think quite yet, but very soon, because the budget has to go to the printer by the end of December. And that's the kind of deadlines that drive this process. You're going to get a budget decision for the fiscal 2011 and out years. The out years are the crucial thing. And you're going to get a policy decision probably announced by the president perhaps, as the report suggests, an invitation to potential partners to work with us in planning the future. That could come as a separate statement. It could come in the State of the Union. But all the readings I'm getting is that this will be a presidential decision, not a John Holdren, Peter Orszag, OMB, OSTP, National Security Council decision. Will be a presidential decision, and the president will want to take credit for it. So I guess the final word is stay tuned. Thank you.
Okay, I guess I'm going to talk about something a little bit different, really focus on the international dimensions of the future of human spaceflight. What I'd like to really do is offer some thoughts on, based on what the Augustine Commission said, but also based on some of the work that we did at MIT last year with the report that David talked about that we issued on the future of human spaceflight, and how sort of locating the future of U.S. human spaceflight in a broader international context. I just want to start with a preamble that in terms of the history of human spaceflight, the first, I'd say 30, 40 years was very much a bipolar situation. You had the Soviet Union and then Russia, United States. Around about 2000, you have a situation when you start to have a multipolar world in the field of human spaceflight. You have, of course, new powers such as new human spaceflight players such as China, but also emerging players such as India. You have a host of older, mature players such as ESA, Russia, of course, and Japan and Canada. I should add that only Russia of these older powers has the independent access to LEO in terms of human spaceflight. ESA, Japan, and, for example, ESA and Japan don't have to rely on the Russians or the Americans to get to low Earth orbit. And one might argue that commercial interests are also sort of getting in the business of human spaceflight. There's a new constellation of players that we have to account for in some sense. It's no longer really the old model. And so what does that mean for the United States, and what does that mean for the future of human spaceflight in general? I think one can concede in some sense that the U.S. role in human spaceflight has eroded, and one might argue for the reasons for that in terms of leadership, why that has eroded. But certainly one of the factors is, I think, the fact that U.S. is dealing with a whole host of nations and entities that are offering incredibly mature technologies now. That so the U.S. is not sort of a sole player in that sense. So in order to really formulate U.S. strategy and in terms of the future, and to really talk about what might happen in terms of an international situation, I'd like to really focus my brief comments on China and India. Partly, one of the things that the Augustine Commission report said was that, human spaceflight has always been sort of a play of international relations in some sense. Of course, during the Cold War, it was competition. In the ISS years, you have a cooperation. And so how does, in sort of looking at this sort of newer world, so to speak, how does that play in terms of new emerging powers such as China and India? And what I'd like to do with these particular cases is to look at their rationales, their goals, why they go to space, and talk a little bit about what goals they're trying to define and articulating, and perhaps speculate on some possibilities for cooperation. China is an interesting case. I mean, most of you are aware of the Chinese human spaceflight program. In 2003, they became only the third nation to launch a human into space, launched on the Shenzhou spacecraft with astronaut or taikonaut Yang Liwei. China has a very diverse and mature set of robotic systems, automated systems ranging from military applications, science, etc. In terms of the kinds of things they're talking about, articulating, this is why we go to space, they offer sort of the usual sort of touchstones: science, economic benefits, national security, national prestige. In terms of human spaceflight, it's clear if you sort of look at what they're saying, really the primary factor here is national prestige. And it's really the single most important factor for them in terms of their human spaceflight project. And that's not to say national security or science isn't important, but I would call them ancillary benefits, really. the 3 Shenzhou missions since 2003 have brought the Chinese government an explosion of sort of enthusiastic nationalistic feeling, both particularly domestically, but also soft power gains abroad. And to give one specific example, which we actually mentioned in our report, we saw the space program as a way to overcome for the Chinese to overcome their stereotype of a producer as a producer of cheap, low-tech goods. And here they are doing something that's extremely high-tech and sophisticated, which projects kind of an image abroad. In terms of goals, I think from our study, it was clear that the Chinese are building a basic level of competence in human spaceflight right now. And building upon that, it seems in the 2020 frame, they're really trying to build a modest human space station in low Earth orbit. And people talk about the moon race with China and all this stuff, and I would argue that all of this is rather premature. It's extremely unlikely, given the pace at which they're going, given what we know about their program, that they would have humans on the moon before at least 2030, and even that is I would consider that a kind of provisional date. And in terms of cooperation, there's been a lot of recent activity on that front. I mean, China has a very vast international cooperation program regionally with Asia. They have an organization called APSCO, in which they have recruited many, many developing nations and work with them. But in terms of human spaceflight, of course, they're pretty much, they've obviously drawn on Russian technology for their spacecraft. But there is, I think, an opening now. I think in November, as you may well know, there was some talk of, there was actually an agreement signed about a possibility for cooperation in human spaceflight. And I think the problem here, and probably John could say more about this, is that one of the problems was the issue of who to talk to. I think that's one of the sort of basic obstacles in terms of cooperating with China. And there are, of course, others concerns in terms of technology transfer, militarization of space, human rights, etc. But I do think that there is an opening right now, and what happens, of course, it's hard to tell, given shifting political landscape. India is a particularly interesting case, too, partly because the Indian space program is at a very crucial transition point. The Indian space program really began in the late 60s as really focused on poverty alleviation and development, domestic development. So they built a whole generation of rather excellent remote sensing satellites, application satellites, etc. Around the early 2000s, you see a fundamental shift in the Indian space program, really a dramatic shift, and this is helped by high growth rates in the Indian economy, a large pool of trained manpower, and a large sort of base of infrastructure in the Indian space program, which allowed them to consider really broader, bigger, and more ambitious goals. What does a global space power do? And I think the discussions, from my understanding and my visits and sort of conversations with people at ISRO, the Indian Space Research Organization, was they really were thinking about what does a global space power do? This was early 2000s, and they sort of focused in on human space flight and deep space missions as two sort of particularly ambitious markers of a global space power. And of course, you see manifestations of that very recently with, in 2008, they launched their first lunar probe to the moon, and which, by the way, brought the Indian space program enormous publicity that nothing before, and they've been launching satellites for 20 odd years, almost 30 years before that. This just one mission to the moon had garnered them an enormous amount of publicity. And of course, in 2006-07, the Indian government announced that they would initiate a human spaceflight program. For the first mission, they're estimating 2014. A government commission earlier this year approved the project, and from my conversations, it's clear that this is going to happen. It's not a question of if, it's a question of when. And so we can expect, given their current funding, probably not 2014, but probably late teens. You might expect an independent Indian human spaceflight program. And of course, I should mention one more factor, the role of China in all of this, in a way that India is playing off China in terms of an implicit, if not explicit, race for kind of maturity and experience in low Earth orbit. And so in some ways there, and we did a little bit of this work in our report, we found that they're sort of accessing some of the rhetoric that was very prevalent in the Cold War between the United States and the Soviet Union, and you see this rhetoric played out in a very contemporary setting between India and China about space, the kind of stuff that Lyndon Johnson would say, first in space means first in everything. And so you see this kind of rhetoric played out, particularly between Chinese and Indian spokespersons. So that's kind of an interesting aspect of that. So I just don't want to take up too much more time, but I want to sort of end with a couple of brief comments. I do think that given this new multipolar world of human spaceflight, that it would be impossible for the United States to ignore what's going on abroad for many reasons that other panelists have mentioned. I find this idea that the Augustine Commission mentioned, leadership versus domination. I think we can lead the way and still cooperate instead of having sort of a domineering role in international cooperation. I think we might have to reconsider this aspect of whether we have international partners in critical paths in terms of future human spaceflight systems, and it might be good to review that and concede that as a one factor in future planning. And finally, my sense is that on a more concrete level, post-ISS, roughly post-2020, we might have to really integrate and think about the ways in which particularly the Chinese or the Indians might play into our human spaceflight program. So I'll just end there with those thoughts. Thanks.
Okay, thanks to our panelists for lots of food for thought, a lot of things to think about and talk about, and we have about 15 or 20 minutes for questions and comments. And so I will request, first of all, if you do have a question, we have 2 microphones here, so please just stand up and line up at the microphones, and we'll go back and forth. And then secondly, especially for the first few minutes, to try to emphasize questions from the students and give the students first place in line for questions and comments. So can begin here.
Hello. My question was kind of related to the flexible path option and looking at destinations other than Moon and Mars, the kind of technology development or the kind of technologies required for that. One thing to think about would be if that would, if all of the technologies required would actually contribute to Moon and Mars exploration, or would you be actually spending resources on things that won't be useful for future exploration? And if that would actually push back the dates rather than helping achieve milestones, that would be interesting to the public. Another thing is the fact that free space missions, I'm not sure if there's as much public interest in those as surface missions, and if that part of the list of goals for the future human spaceflight is actually satisfied by going to multiple destinations rather than actually focusing and trying to push back the time, or rather make the time to surface for Moon and Mars a little earlier. So that's.
Yeah, all good questions. On the technology question, the answer is no. We were actually very careful to think about whether the building blocks that we would need along the flexible path would be blocks to nowhere or blocks to somewhere. The principal investment actually is in a restartable deep space engine that after weeks or months of not operating, you could fire up reliably. And you would need that to go to Mars eventually. And if one was clever about a commonality analysis, you could use that same engine as the descent stage for the lunar lander. So you would, in fact, have been making an investment of part of the significant cost of the lander infrastructure by doing the in-space restartable stage. The only other pieces you really need are HABs, in-space habitats, and you need those to go to Mars, and you need something that's a in-space qualified HAB to inhabit the surface of any planet, although the planetary HABs might be slightly different in design, but might have a lot of common subsystems, ECLIS systems, for example, and power systems. So you can draw a technology path through the flexible path that actually causes that investment to be largely recovered in subsequent missions. In terms of the question about public reaction, I think that's a fair question, and it's one that we had a fair amount of discussion and been a lot of subsequent debate about. There are people who just want to see footprints on planets, that going to a planet means landing someplace, And we were always careful to explain that the flexible path did in fact go to some things. It goes to near-Earth objects, which we've never visited, goes to moons of flyby of Mars, which we've never visited. There's a good metaphor in this that NASA totally underestimated the impact of the Apollo 8 flight beforehand. That is to say, that the NASA thinking had consistently been that the important thing was to get to the surface of the moon. And when 3 astronauts went and circled the moon, there was an enormous public engagement, which was largely unanticipated by that. But it is something that one would have to craft carefully. The last thing I'll say is that we actually did a very careful study in my group at MIT a couple of years ago about what actually made news in the space program by actually going to primary documents like the the New York Times and seeing, what page stories appeared on. And the correlation is pretty simple. The first 3 letters of news is new. When you do something you haven't done before, it's on the first page. When you do something you've done before, it's on page 14. So the flexible path is also designed so that each one of the events actually does something that hasn't been done before. That you go to a new destination or a new capability or new duration or so forth. So that it isn't, the 117th flight of the shuttle to the 23rd assembly flight of the space station, which frankly does not garner much press.
Implicit in Ed's comments and in the report is, and one of the reasons I think, as John said, that we're still arguing about this 50 years later is that the issue raises, what does it mean to really go somewhere? Is orbiting around enough, or is boots on the ground what it means? And one of the reasons that this topic continues to fascinate is that basically a philosophical question like that gets elevated into this very national technical policy debate.
Let me just sort of add one other fact, which is that it really isn't the difference between going to the moon and going on the flexible path. It's really the difference between going on the flexible path and not going to the moon. Because at an investment rate of $6 or $8 billion a year, it takes an extra 3 or 4 years worth of money to build the stuff necessary to go to the moon. So the question is, in those 3 or 4 years when you're building hardware to go someplace, can you in the interim do something with what you've got built so far? It's a concept that Ollie Dweck would call stage deployment.
May I add just a footnote on the Apollo 8. The particular year it took place, which I can't think of right now, 68. If you go back and look at the historical events that took place that year, there were really some astonishing events. That was an unusual year and impactful news. And when Time magazine at the end of the year tried to summarize the year, they had on their cover it was Bourne and Anders and whoever the third was from Apollo.
Jim Lovell.
Jim, of course. Sorry about that. They had it featured that on the cover, which really, as Ed said, I think it came as quite a surprise, the impact it had.
My name's...
It's on.
Okay. Hi, my name is Ben Corbin, and I'm the president of the Students for the Exploration and Development of Space here at MIT. 2 quick questions. I know you were not allowed to make specific recommendations to the president, but if you were the president, which option would you choose? And my second is, how can we better stimulate the commercial space markets so that we get more commercial space transportation?
Let me make a side comment before they respond. Formally, there are not supposed to be any recommendations in the report. If you read the report, it's full of recommendations. I mean, the logical conclusion from the analysis are recommendations. So,
let me observe for the record that I did word check, and the word recommendation does not appear in the report.
But
well, to answer your question, if I were president, I would have to have gotten that position. I would have to be smart enough to know not to answer that question. Ed, do you want to talk about the second part?
I learned from Norm. No, I will stand by John's answer to the question. I think what we were asked to do was to define criteria for evaluation of options based on sound policy principles, to define options and to evaluate the options, and I think we did that. And I think you just have to read between the lines of what would be a likely outcome. I in my brief to OSTP, said there are really three presidential decisions here. There's the decision about the degree to which we'll embrace the international community. Will this be really a global enterprise? And I think our findings on that are fairly clear. The second is, what's the destination? Will we continue the strategy of going exclusively to the moon or follow some variety of a more flexible option? And the third is the budget. And probably it comes down to, John would say, it probably comes down to just the budget. I mean, the president is interested in, if I were the president, I would be interested in providing for the American people something stimulating and exciting and returning of technology and so forth.
You'll never be president.
Write that down somewhere. In terms of the commercial question, if you actually read the report, we actually lay in 4 or 5 mechanisms for the development of commercial space opportunities. Another part, I think, in dealing with the students I deal with, of exciting America's youth about space. So we have the commercial cargo. It's pretty clear that we create the possibility of commercial crew. We identify the possibility of in-space refueling as a way to defy the rocket equation in a sense, but also provide a third market for delivery of cargo to low Earth orbit, which is fuel and oxidizer. In the flexible path, we actually had commercial components that were in the, this really shocked NASA, but it's far enough away that it didn't shock them as much as the Ares 1 trade. The lunar lander being a commercially supplied component, at least the descent stage of the lander being a commercially supplied component, and other components. So we actually laid in the option space a number of opportunities to stimulate the commercial space community.
One of the comments that we heard in the very beginning when we were talking about the overall conclusions of the report was the importance of allowing the NASA administrator to manage NASA. And I was just wondering if you could expand on that a little bit and talk about what you might recommend he look at, and how could he be given the freedom to do what might need to be done in order to bring down some of the fixed costs that NASA struggles with?
That's a very good question. The NASA administrator, were he the CEO of a company, would, I think, find himself in much the situation the aerospace industry as a whole found itself at the end of the Cold War, namely with a very large structure and a budget that doesn't quite fit that structure. And one of the problems they have is that we in this country, and NASA in particular, have been counting on when the shuttle is shut down, all that money that goes to the shuttle will be savings. Well, the fact is that a lot of the money that's billed to the shuttle is the cost of maintaining facilities for whatever programs you want to pursue. And so it doesn't go away automatically. So the NASA administrator would have to have the authority to tailor the size of NASA, both people and facilities, to whatever budget they get. Now, if they get an additional $3 billion, then it might be that they need more people and facilities, but they may need different people and facilities. I really don't know. If they don't get the extra $3 billion, they then have a choice of whether to spend their money on fixed costs or on doing exciting space work. And today, the administrator really doesn't have the wherewithal to address that question, and we think he needs to have that. Now, having said that, I'm well aware that being administrator of NASA is not like being CEO of a company, and he has many more constraints on him. His job is much tougher, and so, but I would hope they would give the administrator, he or she or whoever it is, but particularly this administrator, who I think is extremely capable, the latitude to manage the place to optimize the space program.
Let me give an example of the problem. The fiscal 2010 appropriation for NASA finally came out of the House this week. and it included a provision that NASA cannot change the existing program without the permission of Congress. That's a pretty heavy constraint on management flexibility.
I was just wondering, with all the talk of international cooperation, why none of the 6 options formally included a continuation of the ISS partnership or more of an international participation option, basically.
Do you want to take that?
Yeah, we were somewhat constrained by our ground rules to essentially deal with the domestic parts of the question. In other words, it would not have been appropriate for us to go and start discussing with, in any great depth, with international space agencies or heads of government or anything, which is really the level at which those discussions have to take place. So what we tried to do was to sort of divide the question and say, you know, what are the things that seem to be feasible and logical, and then to write a chapter that says there would be great benefit that would arise if you sat down with the international partners and worked out a strategy by which this was a other than U.S. endeavor, rather than trying to explicitly say, you know, there's an option in which there might be a French upper stage and a Russian lander and so forth, which would have tread beyond our, really beyond our charter, we felt.
And I would add that potential partners are not mature enough in their thinking to be ready to commit to any particular contribution, especially given we don't know what we're doing yet. So, I mean, what is most likely to happen is a presidential invitation, which is what led to the space station partnership, presidential invitation to work together in crafting a global approach.
Right.
How controversial do you think the recommendation of allowing the international partners into the critical path for the programs will be?
John, why don't you take that one?
Not at all. I think that, except for NASA engineers. I mean, you know, Texas is Texas. That's being flipped. But in fact, the people that work on space station have gotten very used to having Russia in the critical path, even before the transportation necessity. So we've learned to do that. We couldn't have space station without Russia. And the whole tenor of the Obama administration is, Secretary Clinton said it very clearly a few months ago, we want a world of partners. And that thinking is being applied at the senior levels to this situation. The idea is having a partnership, not a, as Asif said, a U.S.-dominated managing partnership, uber alles. So crafting that is going to be an interesting challenge for we social scientists.
Hi, I'm Dan Buckley. I'm a graduate student here. I was just wondering if you could comment on how the impact of failure, like mission failures, on all this analysis, both in terms of if one of the remaining shuttle flights doesn't work, how does that impact your forward thinking on all this? And then both with flexible path, if a Lagrange point mission doesn't work, because planning would have to be years out, do we try again? Do we move on to the next stage of the flexible path? And how that would change all of our thinking?
Boy, you know, I think we were very careful to try and say that space is human spaceflight is a risky proposition, that we try to make it as safe as we can, but that one can never give absolute assurances, and that as in fact, the safety criteria that we applied was to recognize that as you went away from the Earth, they were increasingly risky, increasingly hazardous missions. I don't have a specific comment on what would happen if we lost another shuttle, other than to observe that it was the loss of the last shuttle and the CABE report, which really galvanized a broad political consensus that if we're going to send humans into space, we should do it to destinations and in ways that merit the risk of human life, rather than delivery of cargo to low Earth orbit, which is one of the ways in which we use the shuttle. With respect to the flexible path, the Lagrange points in lunar missions are relatively insensitive to phasing. You can always go to a Lagrange point more or less the same way. The missions that are susceptible to phasing are the planetary missions and the NEOs. The interesting thing about the NEOs is that the catalog of them is significantly larger than I had understood, and is growing at a pretty substantial rate. My recollection is hundreds per year. I'm not 100% of that number, so don't quote me, but it's something like that. So that by the time you had to target a NEO mission in 2021 or 2022, there would likely be thousands of NEOs that would present themselves as opportunities of different classes. And, you know, so it wouldn't be difficult to find one that had the right orbital parameters. And if you missed it, you might have to wait a month or two, but you wouldn't have to wait a year or two.
That's known as there's good news and there's bad news.
Yeah. The bad news is that all those NEOs could hit us.
Two more, because our window's closing for the very small schedule overlaps.
We have LOS in 7 minutes.
In the beginning of the report, you make the comment that it's good to give NASA a defined set of goals, and I think that definitely played out in the Apollo. You know, we should go here. Engineers like bounded problems, and yet it would seem from the report that your recommendation is the flexible path. That seems to be the one that you talk about the most. Implicit in that title is flexible. I'm just wondering if you could comment on that.
You want to say?
I'll start out, then I'll turn to Ed. Your point is a very interesting one. I think that one doesn't have to have one specific goal. I think one could have a series of goals. And one of the things I think is important in the flexible path, and I don't want to embrace any one particular approach, but one of its benefits is you don't have a case where you say, send us $70 billion, no, it's $99 billion, and come back in 15 years and we'll go back to the moon. That's a criticism you tend to get. So, and as we said, we think that for safety reasons and money reasons and others, that we're not prepared to go directly to Mars. So, if you take those two views aboard, the idea of having a series of things you can do over time, not only technically, but I think politically and socially, has great advantages. And the fact that you may do them in a little bit different order as you learn more, as you get further into it, I think doesn't matter that much. Ed, do you want to?
Yeah, I would answer the question in a different way, which is that you know, this is really a program of exploration, and we really don't know what we're going to find. You know, when you talk to Jack Schmitt, the last person to set foot on the moon and the first trained scientist, you get a perception that you know, we were really just beginning to understand the field geology of the moon in the last mission. So whatever it is that we do, we should make sure that in the investment, it's $99 billion, by the way, Norm, in this decade, and then another $50 billion or so before you get to the moon. If we're going to invest $100 or $150 billion worth of the nation's wealth, we should make sure that we have the capability to react to what we learn when we start. Whether it's the approach of a NEO, whether it's the discovery of significant resources either on the moon or on near-Earth objects and asteroids. You know, it's too early in this game to say the mission is to land at the South Pole and only to land at the South Pole. There's just too much national wealth that will go into this to end up with a limited set of capabilities. And that's not necessarily an advertisement for the flexible path. It's just an advertisement for taking sort of a capability-based view of space exploration rather than a destination-based view.
And we're not racing anybody.
And we're not racing anyone.
Okay, one more quick question, and then we'll have to wrap.
I'm Jonna Kaplan from the Graybill Lab at Brandeis. My question is that you focused primarily on technological aspects. What about the sustainability of human life in the long-duration space exploration, especially once we leave the near-Earth orbit? Or what about, you know, suspended animation, artificial gravity, all kinds of radiation, asteroids, stuff like that?
Well, that's actually in Chapter 8, I think it is, in the technology section, where we say these are still substantial unknowns. I mean, you can say that with a couple of missions that have extended in excess of 180 days, we have a pretty good understanding of the gravitational adaptation. Larry Young, if he were in the room, would probably, or Chuck Ullman, who is here, I think, would comment on that more expertly. But the real unknown is the radiation environment, and I'll say two things. One is that we were very careful to in both the lunar and flexible path cases to lay out a sequence of missions under which you would gain increasing experience dealing with and observing the human reaction to the residual radiation threats that were not covered by shielding and so forth. But it was actually also something that figured somewhat in our thinking about the extension of the ISS. It turns out that the radiation environment in low Earth orbit is, while not anywhere near as severe as in free space or beyond the magnetosphere, is actually significantly more harsh than on the surface, in part largely due to the absence of the atmospheric shielding. So there is actually some human radiation adaptation or radiation protection research that can be done on the ISS, although none is currently planned that I'm aware of. So what we did is we put this issue in the technology unknown category and said it's one of the high priority things in that category.
Final remarks from the panel?
I just have one last comment about this issue of, I think Ed talked about the issue of the budget being an important aspect and international cooperation and what to do, these three big questions. I think with international cooperation, I think one thing we have to keep in mind is that if the future program looks, whatever it looks like, if international cooperation is minimized, and if we are going on this flexible path option in which doesn't include, say, footprints on the ground, and if other emerging powers such as China and India do have a footprints on the ground approach, and they do manage to do that during the time that we are doing a flexible path approach to, say, L5 or wherever, I think that has a public cost to, a cultural cost to, that we need to really consider in terms of what we're doing in the future. So that's just
wonderful. Please join me in thanking the panel for a fascinating